there and welcome. Today we are diving deep into one of the most fundamental processes in all of biology. It's a tiny microscopic event that connects something as simple as a paper cut to the most complex diseases that humanity faces. So let's get right into it. So let me ask you a question. What could possibly connect a stroke, a bad sunburn, and rheumatoid arthritis? I mean, think about it. You've got a sudden lack of blood flow to the brain, a burn from UV radiation, and your own immune system attacking your joints. On the surface, they seem like they're from completely different worlds, right? Well, what if I told you that at their absolute core, they all start with the exact same event? And there it is, cell injury. This is the universal language of disease. It's the microscopic spark that can ignite so much of what goes wrong inside our bodies. And honestly, if you can grasp this one concept, you're on your way to understanding the very foundation of health and illness. Okay, so we've established that cell injury is the starting point. But what does that actually mean? Before we jump into all the things that can cause it, let's first get a handle on what it even looks like for a cell to be stressed out and injured. I want you to think of your cells as these amazing, resilient little factories. They are constantly adapting to changing conditions, different temperatures, fluctuating nutrient levels, you name it. But just like any factory, they have their limits. When a stressor gets too intense or just lasts for way too long, it pushes that cell right past its tipping point. And that moment, that's cell injury. Now, once a cell is injured, it reaches this critical fork in the road. At first, the injury might be reversible. The cell could swell up, its machinery might slow down, but if you take away that stress, it can bounce back. But if that stress continues, the cell crosses a point of no return. The injury becomes irreversible, and at that point, the cell is destined to die. This can happen in a couple of ways: a really messy, inflammatory breakdown called necrosis, or a quiet, programmed self-destruction called apoptosis. So we know what cell injury is, but what actually causes it? Well, as you can probably imagine, the list of potential culprits is huge. So to make sense of it all, we can group them into a few key categories. So instead of just running down a long, boring list, let's think about these attackers thematically. And the first category, it's all about logistics. It's about failures in the supply chain that stop a cell from getting the absolute essentials it needs to do its job. Let's go back to our factory analogy. What happens if you cut off its power and fuel? The whole operation grinds to a halt. Well, that's hypoxia and ischemia, a lack of oxygen or blood flow. It's exactly what happens in a heart attack or a stroke. And the same goes for raw materials. Too little of something crucial, like vitamin C, which leads to scurvy, or way too much of something, like an overload of iron, can cause the entire system to just break down. To really see just how devastating one of these supply chain failures can be, let's zoom in on what happens when a cell is starved of oxygen. It's not a slow decline. It's a rapid, catastrophic chain reaction. It all starts right here. The blood flow gets blocked, and the cell is suddenly cut off from oxygen, which is the most critical ingredient it needs to make energy efficiently. And without that oxygen, the cell's power plants, the mitochondria, can't produce ATP anymore. ATP is the energy currency that fuels almost everything a cell does. It's like a citywide power outage. Everything just stops. And with the power out, one of the very first things to go are the little pumps on the cell's membrane. These pumps are like tiny security guards, constantly working to maintain the right balance of ions inside and out. Without power, they fail, and suddenly sodium floods into the cell, with water following right behind it. And the direct results of all this? The cell swells up. It literally puffs up like a water balloon. This completely distorts all its internal parts and messes up its function. If oxygen isn't restored and fast, this reversible injury is going to become permanent. All right, our next category covers direct physical and chemical attacks from the outside world. This is everything from the trauma of a car accident to extreme heat or cold to the radiation you get from a sunburn. Poisons, chemicals, and even some medicines can directly assault our cells and throw a wrench in their works. Sometimes the threat comes from other living things. Infectious agents like viruses that can hijack a cell's machinery for their own purposes, or bacteria that release nasty toxins. But in other cases, the threat actually comes from our own bodies. In a tragic case of friendly fire, our immune system can get confused and attack healthy cells, leading to autoimmune diseases like rheumatoid arthritis. And finally, some injuries are just the results of built-in problems. A genetic defect can be like having a faulty blueprint from the start, causing a crucial protein to be built incorrectly, which dooms the cell to fail. And then, of course, there's aging.
that slow, inevitable pileup of wear and tear as our cellular machinery just gradually breaks down over a lifetime. So we've just seen this dizzying array of causes, right? From supply chain failures to external assaults and internal conflicts. They all seem so incredibly different. But this is where the story gets really fascinating. This is such a critical idea. Despite this huge number of causes, it turns out they don't all lead down unique paths of destruction. Instead, all these different roads, they converge. They funnel down into just a handful of common pathways inside the cell. And here they are, the big ones, the final common pathways. It doesn't matter what the initial cause was. The end game often looks just like this. The power goes out as ATP is depleted. The mitochondria, the power plants, are damaged. Calcium floods the cell and activates all these destructive enzymes. And the cell gets attacked by free radicals during oxidative stress, which are like molecular vandals just tearing things apart. Ultimately, the cell's membranes, its DNA, its proteins, they're all shredded. This is the shared script for how a cell dies. So why have we spent all this time on these microscopic details? You might be wondering, okay, this is interesting, but why does it matter to me? Well, because understanding cell injury isn't just an academic exercise. It has profound implications for how we think about our own health and disease. Because this isn't just a biology lesson. This is the story of us. Think of almost any major disease you can name. Heart disease, cancer, Alzheimer's, diabetes. At its very, very foundation, you are going to find a story of cell injury. That's why this is so critical. Understanding these microscopic events is the first step toward finding ways to treat the illnesses that impact every single one of us. And this brings us to a final, really powerful idea. If so many different diseases with so many different causes all funnel into these same few destructive pathways, what does that mean? What could that mean for the future of medicine? It suggests that if we could find a treatment that targets one of these core pathways, say a drug that protects mitochondria from damage, it might not just treat one disease. It could potentially work against dozens. And that is a truly revolutionary thought.